All right, part 2.8, interpreting tables of proportional relationships. You like the flavor of chocolate milk made with 3 scoops of powder and 4 ounces of milk. Which table below shows this relationship? Okay, so we like 3 scoops of powder and 4 ounces of milk. We have to interpret this table to see if this table shows 3 scoops of powder and 4 ounces of milk. And right away we see a 3 and a 4. The problem is it's backwards. This is a classic kind of distractor. It's the wrong answer, and we have to understand why. This does not show 3 scoops of powder and 4 ounces of milk. It shows 4 scoops of powder and 3 ounces of milk. The numbers are backwards. You can't just look at the numbers. You also have to look at the, you also have to understand what they mean. 3 and 4, that's not going to get the job done. You have to know it's 3 scoops of powder and 4 ounces of milk. So you can't just know the numbers. You got to know what they're standing for. This is backwards. This is a proportional relationship table. 3 times 2 is 6. 4 times 2 is 8. 4 times 5 is 20. 3 times 5 is 15. This is a good table. It's just not the flavor that we're looking for, because we want the ratio to be the other way around. We want 3 scoops of powder and 4 ounces of milk. So A does not work. What about choice B? Well, choice B starts out good. We have 3 scoops of powder and 4 ounces of milk. That's what we're looking for. But then they increase 1 in the scoop of powder for every ounce of milk. For every 2 ounces of milk they increase. They increase 2 scoops of powder for 2 ounces of milk they increase. And that's not right. You're not in plus 2, plus 2, plus 2, plus 2. Does not work. 3 is to 4 is not the same as 5 is to 6. If you cross multiply these, they do not work. So is not a balanced same flavor. Think about it. 4 times 2 is 8. 3 times 2 is 6, not 7. This would be too chocolatey to have 7 is to 8. All right, what about choice C? Choice C does work. 9 to 12, 18 to 24, and 21 to 28. And you can see, no, choice C doesn't look like it should work, because you don't start off with 3 scoops of powder to 4 ounces of milk. But you don't need to. If they're all in balance, it shows a proportional relationship, even if that first set of numbers is not there. So it doesn't look like the right answer, but it certainly is. How are we going to check? We're going to check with cross products. Cross products is very similar to cross multiply and divide, and it just goes like this. If you have 3 into 4 and you're trying to check if it's the same as 9 to 12, you multiply diagonally on both sides of the equal sign, and you should get the same number. So 3 times 12 is 36, just like 4 times 9 is 36. So you know that it's in balance. 3 scoops of powder is to 4 ounces of milk, as 9 scoops of powder is to 12 ounces of milk. And I say it's very similar to cross multiplication and division, because it is. If you were to not know what this number 9 is and do 3 times 12 divided by 4, you'd get 9. So cross products is kind of the same as cross multiplication and division. And you can just check to see if 2 ratios are in balance by cross multiplying on both sides of the equal sign. So 4 times 9, 36. 2 times 3, 36. And yeah, if we're looking for a balance of 3 scoops of chocolate to 4 ounces of milk, that is in balance. 9 to 12 is in balance with 3 to 4. How about the next one? 18 to 24, 3 to 4, yep, 72, 72, and 84 to 84. So we are good to go.